Hello everyone. Today we will try to understand what operations are used while defining regular expressions. First, let's try to understand what is regular expression. As we all know, in arithmetics, we can use operations plus and multiplication symbol to build up expressions. For example, 5 plus 1 multiplied by 4. This is an arithmetic expression. Similarly, we can use the regular operations to build up expressions describing language, which are called regular expressions. So, regular operations are used to build up regular expressions, and regular expressions are used in order to build language. In regular expression, let's say union 1 concatenated with this. We will understand each of the operations in a minute. The value of the arithmetic expression, this one is 24, right? This is the result of the arithmetic expression. However, the value of a regular expression is a language. And most of the time, we are showing the language defined by a specific regular expression like this. In this case, the regular expression is that expression that we have written. In this case, the value is the language consisting of all strings starting with a 0 or a 1, and it is followed by any number of zeros. Let's try to understand each part separately. First, the symbols 0 and 1 are shorthand for actually a set. This means a set which includes 0. And also 1 here means that a set which includes 1. So actually 0 union 1 is equivalent to this expression. However, we are not writing this, of course. The language that we are getting from this part of the regular expression is this, actually. It includes these strings, which means, for example, 0, the string of 0, let's say it's the string 1, the string 1, which is 0, belongs to this regular expression, actually. Let's say string 2 is 1. This string 2 is coming from this regular expression as well. However, if we say, let's say S3 is 1, 0, is it coming from this language? No, right? This is not coming from this language because it is not defined by this regular expression. There is no repetition or there is no other operations. And the part, let's select a different color. The part 0, Kleene Star. By the way, this means Kleene Star. 0 Kleene Star means Kleene Star of a set which includes string 0. And its value is the language consisting of all strings containing any number of zeros. As you remember, we defined the language described by the first part of the regular expression. And for the second part, we can also write the language. However, in this one, since it's saying Kleene Star, by the way, we will try to understand what does it mean in a minute. However, for the time being, let's write. It means that 0 or more repetition. So, when you see 0 Kleene Star, it means that there should be 0 or more repetition of the symbol 0. So, empty string, which is shown by epsilon, belongs to this language. And also, 0 belongs to this. 0, 0 belongs to this. And it goes like that. Like the multiplication symbol in algebra, the concatenation symbol, and it is shown by this symbol. However, it is often implicit, and in our regular expression it is actually here, between the first part and the second part. This is concatenation. So actually 0 union 1, 0 Kleene Star is actually equivalent to 0 union 1 concatenation 0 Kleene Star. But it is often implicit. Another example of a regular expression is this one. In this one we used parentheses again, but unlike the other one, we use Kleene Star onto the parentheses. This regular expression starts with the language 0 or 1, and then it applies Kleene Star operation onto that. The value of this expression is a language consisting of all possible strings of zeros and ones. We are using sigma symbol to define the alphabet of a language. In this case, the alphabet of this language, which is defined by this regular expression R, is 0 and 1. Since we can describe the alphabet like this, we can write sigma as shorthand for the regular expression 0 or 1. More generally, if sigma is any alphabet, the regular expression sigma describes the language consisting of all strings of length 1 over this alphabet. So, therefore, sigma Kleene Star describes the language consisting of all strings over that alphabet. So, it is actually means the same thing. So instead of writing this, we can write that one. Similarly, we can also write sigma Kleene Star and 1. Let's say this is a regular expression 2. What language does this regular expression define? It is defining actually the language that contains all strings over that alphabet which ends in a 1. So we can say that the language out of this regular expression, let's write it properly. The language out of this regular expression is, it can be just 1, because we say that it is Kleene Star, so it can only be 1. What else it can be? It can be 0, 1. It can be 1, 1. 0, 1, 0, 1. And it goes like that. So as long as it ends with 1, it is within that language. Let's look at another example. Let's say 0 sigma Kleene Star So actually this language consists of all strings that either start with 0 or end with 1. Let's look at some strings coming from this language. So 0 is in this language, right? 1 is also in this language because in front of 1 we have sigma Kleene Star, and Kleene Star means that 0 or more repetition. So in the case of 0 repetition, we have only 1 here. What else? 0, 0, 0, 0, 1, 0. These two are belonging to this part, the first part. What else? We can also say 0, 1, which actually satisfies both parts. It satisfies the first part, which is saying that it should start with 0. It also satisfies the second part, which is saying that it should end with 1. And it goes like that. As we have precedents in arithmetic operations, we have also precedents in regular expressions as well. And in regular expression, actually, Kleene Star has the biggest precedence. So Kleene Star should be done first. And after that, concatenation. And after concatenation, union should be done. Let's repeat again. The Kleene Star operation is done first. It's followed by concatenation. And finally, union. Of course, this is true unless parentheses are used to change the usual order. So if we use parentheses, the order will change. It is like we are doing the same thing in arithmetic operations as well. And R is a regular expression if R is a symbol A for some A which is actually inside of our alphabet. So it means that, let's say, R is 1 and our alphabet, our alphabet, which is defined by sigma, is also including 1. So in that case, R is a regular expression. It is also saying that R is a regular expression if R is epsilon, which means it's an empty string. So no matter what symbols does our alphabet have, empty string will always be in our language. R is a regular expression if R is an empty set, which is shown by null. So if R is an empty set, it is also a regular expression. Also, R is a regular expression if R is a union of two different regular expressions, regular expression 1 and regular expression 2. In the same way, R is a regular expression if it is the concatenation of two different regular expressions, and R is a regular expression if it is the Kleene Star of some other regular expression. There's a big difference between epsilon and null, which is actually an empty set. So we should be really careful, and you shouldn't confuse the regular expression epsilon and null sign. Actually, the epsilon represents the language consisting of just one string, which is an empty string, right? There is an element inside of this set, right? Which is the empty string. However, empty set means a language which doesn't have any string inside of it. So there is nothing inside of this language. So its length is 0. Let's say language 1 and language 2. However, the length of language 1 is 1, which is the empty string. But the length of language 2 is 0. This is why we are calling it as null. For convenience, we let R plus be shorthand for R concatenated with R Kleene Star. First of all, plus is used to define one or more. However, Kleene Star is used to define 0 or more. Repetition. Actually, the language R plus has all strings that are one or more concatenations of strings from the language R. What does that mean? So, if we take union of R plus with epsilon, actually we can reach R Kleene Star, right? Because this expression actually means that R plus or empty string. And in the case of Kleene Star, as we know, it means 0 or more repetition, so that means the only difference between R plus and R Kleene Star is also accepting empty strings. So if we take union of empty string with R plus, we can reach R Kleene Star. In order to write regular expressions, we will follow a simple logic. First, we will design a DFA, deterministic finite automata. This is the first thing that we will do. Then, after designing the deterministic finite automata of what we want, as you know, deterministic finite automata is used to determine if a string belongs to a specific language. After designing the DFA, we can convert this DFA into regular expression easily. Actually, you can also get DFA from regular expression as well. So, it is not just one way. We will look how we are doing it in future videos. But for now, I wanted to mention about some basic regular expression operations, what they mean, and how we can try to understand them by using a simple logic. Actually, how it is similar to what we are doing in arithmetic operations. They are following literally the same logic. However, what they are doing is completely different, of course. So, by using this analogy, I hope it makes it easier to understand. I hope you enjoyed while watching this video. Thank you for watching and see you in the next lecture. Bye.